Oklahoma has adopted the 2020 National Electrical Code, or NEC, with no state amendments. However, for projects on Indian reservations, it is crucial to consider that tribal governments may have their own building codes. It is advisable to contact the tribal council to inquire about specific requirements. The NEC requires a minimum of 2 ground rods for a 200 amp service on a wooden building. Certain tribal codes might mandate additional grounding measures such as a buried ground wire or a grounding ring around the building's perimeter. Even if there are no local authority inspections, adhering to the NEC and any applicable tribal codes is essential to ensure the electrical system's safety and reliability. Oklahoma's relatively high altitude can influence conductor ampacity. It is important to consult the correct ampacity tables for the reservation's altitude. Given Oklahoma's fluctuating temperatures and occasional tornadoes, it is recommended to use weather-resistant materials and install appropriate overcurrent protection. It is also important to contact the tribal council to determine if permits or licenses are needed for electrical work on the reservation. It is essential to contact the tribal council to inquire about any specific building codes or electrical requirements. The NEC and all relevant tribal codes must be followed when installing the electrical system. Weather-resistant materials and suitable overcurrent protection should be used. If necessary, a local electrician familiar with tribal codes and conditions may be hired. Let's delve deeper into each of these considerations. Firstly, regarding tribal codes, it's important to understand that while the NEC provides a baseline for electrical safety, tribal governments possess the autonomy to enact their own, potentially more stringent codes. These codes may address specific concerns relevant to the reservation's environment, infrastructure, or cultural practices. Contacting the tribal council early in the project is paramount to ascertain whether such codes exist and to obtain the necessary documentation outlining their requirements. Secondly, concerning the grounding system, the NEC 2 ground rod requirement serves as a minimum standard. However, the efficacy of grounding can be significantly affected by soil conditions, which can vary considerably across different locations. Tribal codes might mandate enhanced grounding techniques to compensate for poor soil conductivity, ensuring a more robust path for fault current to return to the source. This might involve the aforementioned buried ground wire, also known as a ground ring, which encircles the building and provides a greater surface area for dissipation. Thirdly, while the absence of formal inspections might seem to offer flexibility, it's crucial to remember that safety and code compliance remain paramount. The lack of inspections should not be interpreted as an excuse to cut corners or deviate from established standards. The electrical system's integrity is directly linked to the safety of the building's occupants, and any compromise in quality could have severe consequences. Self-inspection, thorough documentation, and adherence to best practices are essential. Fourthly, altitude's effect on ampacity stems from the reduced air density at higher elevations. This lower density diminishes the air's ability to dissipate heat, causing conductors to operate at higher temperatures for a given current load. The NEC provides ampacity correction factors that must be applied to compensate for this effect. Consulting the appropriate tables and performing the necessary calculations is crucial to ensure that conductors are adequately sized for the intended application. Fifthly, Oklahoma's extreme weather conditions necessitate careful consideration of material selection and installation techniques. Weather-resistant materials, such as those with ultraviolet or UV protection, are essential to withstand the sun's intense radiation and prevent premature degradation. Overcurrent protection devices, such as surge protectors and ground fault circuit interrupters, or GFCIs, are also critical to safeguard against lightning strikes and other electrical anomalies. Sixthly, navigating the permit and licensing landscape on tribal lands can be complex. Tribal governments often have their own regulatory frameworks, which may differ significantly from those of the state or local municipalities. Contacting the tribal council is essential to determine the specific requirements for electrical work on the reservation and to ensure that all necessary permits and licenses are obtained. Seventhly, when it comes to weather-resistant materials, it is important to consider all of the potential environmental factors that could affect the electrical system. In addition to UV radiation and extreme temperatures, Oklahoma is also prone to high winds, hail, and ice storms. Choosing materials that are resistant to these elements is essential to ensure the long-term reliability of the system. For example, using weather-resistant electrical boxes and fittings can help to prevent water from entering the system, which could lead to corrosion and electrical shock hazards. Similarly, using conductors with a durable outer jacket can help to protect them from abrasion and damage caused by wind and ice. Eighthly, it's beneficial to consider hiring a local electrician familiar with tribal codes and conditions. Local electricians will note the unique challenges of working on a reservation, such as the availability of materials and equipment, the accessibility of the site, and the cultural considerations that may need to be taken into account. They will also be familiar with the local tribal codes and regulations, which can save time and money in the long run. Ninthly, it's vital to focus on the specific requirements for a small church. Given the building's relatively small size, a 200 amp service may seem excessive. However, it's important to consider the potential future needs of the church, such as the addition of new equipment or appliances. It's also important to ensure that the service is properly sized to handle the load of all existing equipment, including lighting, heating, and cooling systems. Tenthly, focus on adhering to the 2020 NEC. Some key updates include the 2020 NEC revision addressing arc flash hazard warnings. The 2020 NEC Section 110.16b requires service equipment rated 1000 amps or more to have a field-marked arc flash label. This section used to be applicable only to industrial locations, but now is required in commercial locations as well. There are also new requirements for emergency disconnects. Section 230.85 requires a readily accessible outside emergency disconnect for dwelling units. This is intended for first responders. Another 2020 NEC change involves surge protection. Section 230.67 now requires surge protection for dwelling units. This should be a Type 1 or Type 2 surge protective device, or SPD. It must be installed at the service equipment. 11thly, focus on grounding and bonding for safety. Grounding and bonding are critical for safety. Grounding provides a path for fault current to return to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding ensures that all metal parts of the electrical system are at the same potential, which also helps to prevent electrical shock. It is important to follow the NEC requirements for grounding and bonding, including the use of proper grounding electrodes, grounding conductors, and bonding jumpers. 12thly, consider the impact of voltage drop. Voltage drop is the decrease in voltage that occurs as electricity travels through a conductor. Excessive voltage drop can cause equipment to malfunction or fail. It is important to calculate the voltage drop for each circuit and ensure that it is within acceptable limits. The NEC provides tables and formulas for calculating voltage drop. 13thly, when calculating the load, remember to include all loads, including lighting, receptacles, heating, ventilation, and air conditioning, or HVAC, equipment, and any other equipment that will be connected to the electrical system. It is also important to consider the demand factors that are allowed by the NEC. Demand factors allow you to reduce the size of the service based on the fact that not all loads will be operating at the same time. 14thly, when selecting conductors, it is important to choose the correct size and type of conductor for the application. The size of the conductor must be sufficient to carry the load current without overheating. The type of conductor must be suitable for the environment in which it will be installed. For example, conductors that will be exposed to moisture must be rated for wet locations. 15thly, remember that overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. It is important to select the correct size and type of overcurrent protection device for each circuit. The NEC provides tables and guidelines for selecting overcurrent protection devices. 16thly, it is important to use approved materials and equipment. Approved materials and equipment have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or UL. Using approved materials and equipment helps to ensure the safety and reliability of the electrical system. 17thly, it's good practice to document the installation thoroughly. Accurate documentation is essential for future maintenance, troubleshooting, and modifications to the electrical system. This documentation should include a detailed electrical panel schedule. This schedule should list each circuit, the loads served by each circuit, the size of the overcurrent protection device for each circuit, and the wire gauge. The documentation should also include a set of as-built drawings that show the location of all electrical equipment and wiring. It should show the size and type of all conductors, the size and type of all overcurrent protection devices, and the location of all grounding electrodes. This will help ensure safety and code compliance. 18thly, remember to test the installation. Testing is essential to verify that the electrical system is installed correctly and that it is operating safely. This includes testing the grounding system, testing the insulation resistance of the conductors, and testing the operation of all overcurrent protection devices. 19thly, it's important to stay up to date on the latest codes and standards. The electrical codes and standards are constantly evolving. It is important to stay up to date on the latest changes to ensure that electrical work is safe and compliant. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. 20thly, specific to a church, it's useful to consider future expansion. While the initial design might cater to a 1,200 square foot building, churches often expand over time. Planning for future electrical needs during the initial installation can save significant costs and disruptions later. Consider installing a larger service panel than immediately necessary, running extra conduits to anticipated expansion areas, and ensuring sufficient space for additional circuits in the panel. This forward-thinking approach will allow the church to accommodate future growth without major electrical system overhauls. 21stly, focus on energy efficiency. Churches, like any other building, can benefit from energy-efficient electrical design. Consider using LED lighting throughout the building, installing occupancy sensors to turn off lights in unoccupied areas, and using energy-efficient appliances. These measures can significantly reduce the church's energy consumption and save money on utility bills. 22ndly, it's helpful to consider accessibility. Churches often serve a diverse population, including individuals with disabilities. Ensure that the electrical design complies with the Americans with Disabilities Act, or ADA, requirements for accessibility. This includes ensuring that light switches and outlets are mounted at accessible heights, that pathways to electrical equipment are clear and unobstructed, and that audible and visual alarms are installed to alert individuals with hearing or visual impairments. 23rdly, consider emergency power. Churches often serve as community gathering places during emergencies. Consider installing an emergency generator or battery backup system to provide power during outages. This will ensure that the church can continue to operate essential services such as lighting, heating, and communication systems during a crisis. 24thly, when thinking about lighting design for churches, it is crucial to create a welcoming and functional environment. Consider using a combination of ambient, task, and accent lighting to create a balanced and visually appealing space. Ambient lighting provides overall illumination, task lighting provides focused light for specific activities, and accent lighting highlights architectural features or artwork. Churches may also require special lighting for religious ceremonies or performances. 25thly, it's a good idea to provide adequate receptacle outlets. Ensure that there are sufficient receptacle outlets throughout the building to meet the needs of the occupants. Consider installing additional outlets in areas where electronic devices are commonly used, such as near pews, in meeting rooms, and in the sanctuary. It is also important to install ground fault circuit interrupter, or GFCI, protected outlets in wet locations such as bathrooms and kitchens. By following these guidelines, the electrical work on the church and the Indian reservation will be safe, reliable, and compliant with all applicable codes and standards.